of today, just doing as much practice as I can on basically factoring first and then simplifying, multiplying, divide. I think we need to try and get those guys as strong as possible, because it's probably been a long time and there's a lot of little variations in that process that you might not have seen. So you might be quite comfortable with most of it, but I'm sure if I try hard enough, I'll come across some examples that you will think, oh God, I've forgotten about that kind of situation or whatever. So hopefully it'll be good for you. And then the second part of today is that we're going to look at how do you add and subtract fractions. Now, for the homework, you only need to do up to the multiply, divide stuff. The add and subtract is the next one, but I'd like to give you a little head start, because next week we'll be doing the add and subtract stuff. That's when it's due, right? And we'll also be doing the applications, which typically cause a lot of trouble. And that's everything that we need for the midterm. And so I know I'm looking ahead again, but I want you to be as prepared as you can be for it. So first thing I am going to do, I hope this is going to work, I'm never quite sure, is this guy. If you go online into Canvas, you will find that I have put this PDF, it's called factoring. And so if you have any issues with any particular type of factoring, maybe it's common factors, maybe it's difference of two squares, whatever, you can find some information here. So I'm just loading up to give you an idea of what it looks like. And I'll stop from time to time. Oops, let's stop there. Here's one of the ways in which you would factor something. It's called common factors. So for instance, if you were going to do an expression like this, you pull out the common factor of 5, and now it's factored. And what I then do is I just give you lots of examples with solutions. Here's an example where you pull out a 5 and an x as a common factor. And so essentially you get lots of practice at looking at examples. So if you feel you need some help on this, you can certainly do that. And there's lots of different versions of common factors. Look at this one, example 9. 4 lots of ax plus y plus 6 lots of bx plus y. The temptation in that question would be to distribute everything and then collect like terms and then go look for some kind of common factor. But actually that wouldn't work very well. What you've got to realize is even something like x plus y is a common factor. And if you pull x plus y out as a common factor, and while you're at it, maybe pull out a 2, can you see that 2 gets used up, a is left over, and the rest is gone? So this is what you would end up with. So this here is just a resource. If you're great at factoring, you probably will never look at this, but hopefully there's at least something in here. And I go on and I give you some examples, and the answers are at the bottom. So if you want to do some practice, you can do that. And let's pause on this fella. There we go. So are we cool? This is what a resource that I've put out there for you. So let's close that off. Let's go in. And I'm going to spend a little bit of time first, as I said, talking about factoring. So I'm going to go over, that didn't work. What the heck did I do wrong? I know what I didn't do wrong. Why is there always technical issues? Hey, I fixed it. I think I fixed it. Are you looking at my whiteboard now? It's not kind of line board. Right, good. Let's look at common factors. So all we're going to do for this first part is just do the factoring part, right? It's not going to have anything to do with fractions, just that process of how to factor things. Here are two terms. Typically, most questions have got two terms to them. Is there a common factor in these two that's a number? And if there is, can you just like shout it out?
3.
Agreed. So I'll pull out a 3. Now there's definitely some choices here. Would you agree that since there's an x squared and there is an x, we can pull out some power of x as a common factor? Well, do you pull out x or do you pull out x squared when you've got a choice like that? Which one do you always choose?
X.
Right. Isn't there a rule that if you have different powers like x cubed and x squared or z cubed and z or something like that, that you always pull out the smaller of the two choices as your common factor? So if one of them's an x and one of them's an x squared, you pull out an x. If one of them is y to the 5 and the other is y cubed, then you pull out a common factor, right? And the power that you choose is the smaller of the two. So that's the part of the process we call the common factor part. And then you do a big bracket like this, and you look at these terms and you remove or adapt, whatever you want to call it, these terms. So let's see what I get. 3 kills off a 3. Wouldn't an x squared only have one of its x's cancelled out? And won't the y cubed have all the y cubes cancelled out? So basically all I'm left with an x. And if I did this correctly, shouldn't x times this be that guy? And it is. And then I put a plus, and then I say, okay, 3 cancels into that guy 3 times, the x cancels it totally, and the y cubed cancels it, well, 3 of the powers, but doesn't that leave you y squared? And this is considered the factored version. And then what would happen is that you'd have some other guy on the bottom that you did a similar thing to, and then this will cancel this, and that will cancel that, and a whole load of, hopefully a whole load of things get killed off, and what's left is your final answer. We code that guy? Common factors? Do you want me to do another one? Are you comfortable with that type of factor? I see nods. I'll go for nods. Right, let's this is common factors. I'll call that number 1. So second thing we're going to look at, have a name. They're called the difference of two squares. Now, when you factor a difference of two squares, first thing you have to know is when you're even looking at a difference of two squares. So in very generic form, that's what a difference of two squares looks like. Something squared, take away something squared. It's a difference, that's what subtraction means, of two square things. So I kind of like the name, a difference of two squares. It kind of gives you an idea what the thing looks like. So you could get that guy to factor, right? X squared, take away 9. Now, although 9 doesn't have a little square on it, isn't 9 3 squared? So it really is a square. So you always get, in a difference of two squares, the same two terms, x and 3, added, and the x and the 3 subtract. And that's it, finished. I mean, it's a one-liner. If you recognize that it's a difference of two squares, can't you just write the answer in one line? You don't need to do something in between and then you fix it. Is that a difference of two squares? Yeah. Isn't that really just 2 squared? And that's y squared. So 2 goes first. I like to do the add first, but there's no reason why you can't do the subtract first if you feel like it. How about this fella? Is that a difference of two squares? Yeah. It's probably one of the ugliest difference of two squares you're ever going to see, right? Hasn't it got numbers and layers, but we can still factor it. It's going to be two things added and the same two things subtracted, right? That's the shape that this has. Yeah, I'm going to get the first thing from 25x squared. If it was just 25, wouldn't I write the number 5 down? And if it was just the x squared, wouldn't I just write an x down? But since it's 25x squared, do you see why I write 5x down? Now, using that same argument then, shouldn't this become 4y? And then you go and you factor and you cancel with some stuff and it looks pretty at the end. Are we comfortable about difference of two squares? You happy about what they look like and what they look like when you factor them? The third thing that we're going to look at factoring are called trinomials, sometimes also called quadratics. And they have a look to them. They're always made up of three terms. And there'll be a squared term, the single variable term, and typically a number. And to qualify as a simple trinomial, you can only have one of these. So it can only be x squared plus some stuff, y squared plus some stuff, right? W squared plus some stuff, right? It has to have that look to it. Now, when you factor a simple trinomial, you get a double bracket. The x squared guarantees that these two guys are x. And then you look at this fella here and you say a sentence something like this. You try and find two numbers that multiply to get -6. But when you add the two numbers, you get +5. So you look at this number here and you say, okay, I'm going to look at all the different ways I can think of getting -6, right? Two numbers that multiply. There is a rule that I didn't write in the sentence. The numbers have to be whole numbers. So don't go looking for 4 times 1 3/4 or any weird combinations. That's never going to work. Don't even try it. It has to be, 3 times 2 and 6 times 1, right? They have to be nice numbers. So you look for two numbers that multiply together, they give -6. And when you add the same two numbers, you get +5. Now, you probably already know these numbers, but imagine you were trying to do it in your head. Would you agree that's the only 4 combinations that get you -6, that use nice numbers? So your answer has to be one of these, doesn't it? And so the one you choose is the one that adds up to +5. And in this case, it's that one there, isn't it? You see it? So the -1 and the +6. I hope you've done enough practice at these kind of questions that you get good at them. You definitely should get faster the more you do. Is that the basic way that you were taught whenever you were taught how to do factoring? Right, so we cool? Now, before I'm going to do a couple more of these, before we do any more of these, Why did I only do a plus and a minus? Why don't I have two negatives here? Or for that matter, two pluses? Why do I know that those were never, ever going to be candidates?
Because the negatives would cancel out and make it a positive 6.
Yeah, two negatives would make a positive 6, right? And two positives would definitely make a positive 6. So you sometimes get a clue out of here what kind of choices you should do, right? It's not just 1 and 6 and forget about the sign. The sign is part of the process, right? If that had been plus 6, wouldn't I change my rules? If that had been plus 6, wouldn't my combinations be 1 and 6, both positive, and 3 and 2, both positive? In fact, that's my only two choices. And it would have to be a different question because it wouldn't work in that case, right? How about this one? I'll set up all the parts that I know for sure are going to be there. Two numbers that multiply together give me plus 15. But when you add those same two numbers together, you get negative 8. Let's talk about choices here. I know you might already have the answer, but for those people who are kind of rusty, it might help me to write down their choices. It is plus 15, but since they have to add up to negative 8, isn't that a clue that both numbers are negative numbers? So I don't need to worry about 5 times 3, for instance, right? Positive 5 and positive 3. So I'm going to look at negative 1 and negative 15. Would you agree they give me a choice that might work? And then I would do negative 3 and negative 5. And that would do a choice. Is there any other combinations, or is that kind of the end of the line? I'm seeing some nods, so I'm assuming that you're agreeing with me. That's the end of the line. Which one of these two is actually the one that's going to work?
3 and 5.
3.
Yeah. Don't worry if you say both at the same time. I'd rather have two answers than none. Right? 3 and 5. Well, could I have written the answer like that? Yeah. Do you know that mathematically these two are identically, by identical, I don't mean they're identical, that's a bad choice, are equivalent to each other, that's a better word. And so it doesn't matter if you say the 3 and the 5 or the 5 and 3, it's whatever one comes into your head. Very often you can do a lot of this in your head, don't you? Just kind of scan through these numbers and, that's the one that works, and you write it down. Are we good? So I'm going to pause a little minute and I'm going to give you a couple of examples just to try out, right? Just to, convince yourself that things are fine. I want you to factor that one. I want you to factor that one. And then I want you to factor that one. Again, I'm not going to give you a lot of time. I'll give you a minute and a half, 90 seconds. That's 30 seconds each. Okay. Common factor. Simple trinomial, simple trinomial. Agreed? What you do here is not the same as how you cope with this one. So I'm going to look at 3 and 30, and I'm going to say 3. Agree? I'm going to look at a squared and a, so I choose the smaller one, which is a. I'm going to look at b cubed and b, and I'm going to pick the smaller one, which is b. And I'm going to look at c to the 4 and c to the 5, and I'm going to pick the smaller of the two, c4. These are called the common factors, right? Let's see what happens. 3 used up, that cancels, but you're still left with an a. This cancels, but you're still left with a b squared. This completely cancels. And then you use these same guys over here. 3 cancels into 30, leaves 10 behind. A cancels into A, totally gone. B cancels into B, totally gone. C to the 4 cancels C to the 5, but you still have a C left over. Are we comfortable with that process? Right, so hopefully you got the same thing. I'm taking volunteers for the next one. Anybody want to just tell me the two numbers and we are good to go?
-5 and -2.
Have you noticed that there's only one answer to those questions? So if you've got another combination, apart from the obvious x minus 2, x minus 5, right, that works as well. But there really is only one answer to these questions. Anybody want to volunteer this one then?
X plus 4 squared.
Oh, very good answer. Do you notice in this case they're both the same? And you can certainly use it that way. You can use it that way. I kind of like this, but they're both correct. Are we good? Right, so let's move on to our fourth. I said there's 5, so we're getting our way through them. And this one's going to slow us down, I think. Complex trinomials. Also, you could call them quadratics. Well, what makes them different from simple? In a simple trinomial, you always have one x squared, right? It's x squared plus stuff, y squared plus stuff, you know, things like that. In a complex trinomial, it's not x. It's maybe 2x squared, for instance. And then it has so many x's in the number. So the only difference between these two is that instead of an x squared, you have a multiple of x squared, right? 2, 3, 4, that kind of number. And they might even go as high as 7 or 8 sometimes if you're really unlucky. That makes it a complex trinomial. And that kind of changes the rules a lot. You would think, if I can do simple, I'll be able to do the complex ones. You know, how hard can that be? It is quite hard. So, here's an example of one. Try and slow down the process. I get a feeling the last time I did it too quickly. It's 2x squared plus 5x minus 7. The first thing you do is you figure out what the x's are. Now, in this particular question here, can you see that the only one that's going to work is 2x and x, right? That's the only way you can get 2x squareds. But later on, you're going to get much more awkward ones. In this case here, it could split as a 4x and an x, but couldn't you also get it by doing a 2x and a 2x split? That means that when you do these kind of guys, there might be, the answer might be in there. And then you try out all the combinations and none of them work. And the reason none of them work is because the right answer is in there. And it's unique. By that I mean there's only one answer to get. Now, you know how Murphy's law works with me? See if it's one and it's quite hard and I can't figure it out and I set it up and I say, okay, I'm just going to keep going until I find it, right? Trial and error, essentially. Do you know if I pick this one, it's always that one? That's the kind of luck I've always had. And you see if it's that one there? It's always this one. And it doesn't matter if I try and second guess myself. Oh yeah, if I pick the first one, it's going to be the second one. So I'm going to pick the second one and try it out first. When I try that logic, I still get caught out. It's like there's a factoring elf sitting on my shoulder, whispering to me the wrong one to do first. Right? Now, I have met people who are decidedly annoying, who do these questions, and they say, yeah, I do those. It's always the first one that I pick. I get really lucky, and it's always that one, and it works. And I get, how do you know? You don't. You just do it until you get the right answer. So let's go back here. The 2x and the x. You still use this number. And you still should write down, this is how I would do it anyway. I'm going to do the trial and error method, and some of you know all sorts of other techniques, and if they work, please continue to do them. But let's just go the trial and error. I need two numbers that multiply together to give me -7. At least that's the same. Now, when I think about that, I get -1 and +7. But don't I also get +1 and -7? And unfortunately, here's the kicker. The order is now important. See, when you're doing a simple one, see if the number was +2 and -3, it really didn't matter which one you made first, which one you made second, it always works, right? On the simple ones, order is irrelevant. But in this case, the 1 and the 7, positive and negative, where you put them is important, because if I put it here, it's next to a 2x, but if I put the same number over here, you see it's next to an x, and when you FOIL it out, it's going to be different, right? But at least I know one thing. There's only 4 guys, and one of them has to be right. Now, the reason I call this trial and error is that sometimes that's what you do. You guess. You pick one, you try it out, and if it works, you stop because you've got the answer, right? And if it doesn't work, I guess that's the error part of the name, you go and you pick another one. Is anybody want to give me a shot? And I don't mind if you just guess, because you've got a 1 in 4 chance, haven't you? And we'll show you whether or not it's right. So which one of these 4 do you think is going to work for this guy here?
+7 -1.
So imagine I decided to do +7 -1. So I'm choosing this choice, right? And I've written it down. How do I check that it's actually the right answer, the one that works? You FOIL, agreed? Seen some of you saying that. You FOIL. Do you need to do the whole party FOIL? Because I want to save time. Do I need to do the first part? No, that's going to be okay. That's guaranteed to work. Do I need to do the L part? No. Do you know the only part I need to do is the middle bit to see how many X's I get? So to reduce my workload, I only focus on the O and the I. Well, let's see what that gets me. 2 times that guy is, I guess, -2x, and that guy is +7x. And does that get me +5x? Yes, that was the right answer. You see how that works? You pick a choice and then you do a quick multiplication out just to double check on it. Can we pretend that someone gave me that choice, right? So I would end up with 2x take away 7, and I'd also end up with x + 1. So when I go this way, did I just write? Yeah, I'm good. I go this way, I get what, +2x, and when I go this way, I get -7x, and that gets me -5x. And I look and I say, darn it, I wish that had been plus. But here's a little trick. If you do a combination and it almost works, but the sign is wrong, right? You get a -5x and you were on the hunt for a +5x. Doesn't it mean that these two numbers are almost perfect? What's the only thing I need to do to fix it? Switch them, right? Switch places. So although it is trial and error, isn't there at least some ways in which you can reduce your workload, right? You might have 4 choices. Pick one. Has nothing to do with the answer. Well, don't pick the one that's a switcheroo, because that's going to probably have nothing to do with the answer either, right? Move on to your third choice. Oh, it's almost the right answer, but it's plus 10x, and I was wanting negative 10x. Oh, that's easy. Just go to your fourth answer, right? The one that has them switch round, right? First is second, second is first. That one will work. Now, as long as there's not 220 combinations here, this technique will work, but they're never going to give you a question with 220. Most of these questions, I think, are 6 or 8 at the most, and you're more likely to get 4, right? So it is possible. So let's look at this one, which is kind of at the horrible stage, right? This is at the beginning of the complex ones. This is like towards the end of difficulty. So do you want me to go 4x and x, or do you want me to do the 2x and 2x split? Which one do you want me to do? And it doesn't matter if we're wrong, because we're going to eventually get it work anyway. And this time I want to blame you when I pick the wrong one, because right now I honestly don't know which one's going to work.
2x and 2x.
Right, so that guy got in with the 2x and the 2x, so if he's wrong, it's not my fault, right guys? It's his fault.
Exactly.
Now, the number that we're going to be focusing on is this number. 14, it's got some choices, right? I could go -1 and plus 14. Agreed? Couldn't I just switch the sign and go +1 and -14? Oops, I seem to have more digits than I need. There we go. Give me another combination. There is actually only one more, isn't there?
-2 and +7.
And +2 and -7, agreed? But wait a minute, don't you have to switch the order? So now I'm going to have the +14 and -1, the -14 and the +1, the +7 and the -2, and the -7 and the +2. So if I try and separate them in my brain in some way, because I'm a visual person, that's kind of at the top end of choices. There are 8 choices here. Do you want to give me an example?
+7, -2.
Okay, so we're going to go +7 and -2, and we're going to try it out and see if it works. Right, so if you do the outside, you get -4x. If you do the inside, you get +7x. That ends up being +3x. So I am not going to use any of those. And the reason I can kill that one is it doesn't work. But why can I kill all the other ones? Oh, excuse me. Did I kill? No, it's okay. I thought I killed one that I shouldn't have. Do you know if you switch these around, especially, won't you just end up with things like -3x and some other combination that's not your friend? Okay. 4 guys to pick from.
I think you missed a 2 on the second question. It should be 2x -2.
Oh, darn it in space. -4. Oh. Oh. Something interesting is happening. Stop looking, we found one. So I apologize for the person who said that, and well done. There. If what I had said at the beginning had been true, do you know I would have then moved on to the other 4 and tried them out? And do you know what I would have done? None of them would have worked. And why? Because it was up here that the answers were living, right? Those questions look so similar to the simple ones. The simple one you can do in 30 seconds, right? and some of you already have done it, right? They're pretty quick. Do you know some of these complex ones? You could spend 10 minutes because of the combinations that are out there and which one works. Let me try another one. Give me a minute to figure out what I'm going to make this. Check again. Okay, I have 3x squared. How do you think that's going to split? Do you think there's only one way that's going to happen? I agree. See nods. I like to put the big number first, but that's just cosmetic. So 3x and x. At least I don't have, you know, a 2x, 2x combo, you know, like that going on. So that's reduced my workload. On the other hand, 16 is not very good, because doesn't 16 have lots of ways in which it can happen, especially negative 16. So there's -1 and plus 16, and then there's +1 and negative 16. And then you could go -2 with +8 and +2 with -8. Great. Is there any other combinations out there?
Swap them all.
Oh, I'd still like to swap them, but is there any more combinations that have numbers that I haven't?
Negative
Done.
4 and plus
4 and
4.
4.
Yeah, the 4 and 4 one. And what you were right, what you said. So there are 6 guys here, and basically I'm going to swap them. Do you know I'm not going to write the swaps this time? Because see if one of these guys ends up giving me -2x. So can you imagine one of these 6 guys, and I do it and I get -2x. Isn't that good news? I know it doesn't work, but if it does give me -2, don't I just switch the guys around a little bit and we're kind of good to go? That's what I'm hoping for anyway. Now, anybody want to jump right in and tell me a combination that works?
+8, -2.
What, positive what number and negative what number?
8
Anybody
and
got
2.
that? You're going to put an 8 there, and you're going to put a 2 there. Let's double check it. Looks good to me. That guy's 8x, and that guy is -6x, and there's your positive 2x. Agreed? What would have happened if I'd done that? Right, almost the same. Well, I would have got eventually -2x. Do you see that getting close is good news? Because if I get -2x, wouldn't I just look at these and say swap the signs? And that allows me to, even if theoretically there's 12 answers, aren't there only 6 answers that you need to check? Because one of them will work with the partner and you can just switch the signs, that kind of rule. Okay, I'm going to give you one to do it, and then we'll move over onto, I should say over, onto the last type. So, got to figure some really, I'm going to be really nasty to you. Sorry about this, but if I give you a really hard one, then the easy ones are going to look great, right? So it's going to be a 5x plus a 7x, and now I'm going to cheat off screen. Two minutes. Factor that bugger. I'm not helping you here because I'm just giving you a head start, right? You know it's going to go that way. Okay, we're going to be finishing this in a minute. I hope someone's got the right answer, but let me give you some of the thought processes. Can you see that in these 4 boxes, I've put the 8 choices that you could have? And there's not a lot of ways of getting 34. It is quite a big number, but I don't think I missed anything, right? Okay, now I've grouped them together in pairs. And the reason I'm doing that is to try and maybe explain a little bit more clearly what I mean by you only need to do half the questions, for half the choices. Suppose I do that top choice and it doesn't work. Do you know there's no advantage of doing the other one? It won't work. If any one of these pairs gets me an answer that is a 7x or a negative 7x, won't I be able to figure out what the answer is? So say if I do this one and I get negative 7x, doesn't it just mean the other one's the answer? So what that does is it reduces the amount of choices that you need to do guesses with, right? Trials with. Now, I believe I have the answer. Anybody else got the answer?
Positive 17, negative 2.
I guess I should check it, right? Just to make sure, but it looks good to me. If you do the outside ones, you got that, Phil. If you do the inside ones, you get that. What's that? A 17x, take away a 10x, bingo. Suppose that wasn't my guess. Suppose I tried this one, right? Do you notice it's the same 2 numbers with the pluses and minuses in the wrong place, right? If I had done this one, I would have got negative 17x plus 10x. I would have got negative 7x, but I would have been happy with that guess. Because isn't that a guess that all I need to now do is switch the plus and minus around and I'm good to go? Right. Since this is a very intensive process, right, you might have to guess a lot of choices before you find the one. Anything that can reduce your workload is helpful. So I hope this idea of putting them into little pairs and only picking one of the pairs helps you reduce the amount of guessing, right, checking if you want, right, that you need to do before you find the one that works. Any questions about that before we move on to the last type, number 5? No? It doesn't have a specific name, so I'm just making a name up for these kinds of questions. These are special cases with 2 variables. So they are going to look like this. They will be trinomials. That means there's going to be 3 guys to them. They will look very like a normal trinomial. The only major difference is, do you notice that they contain 2 variables instead of the typical 1? So these are the questions I mean by special cases with 2 variables, right? I had to give them some kind of name, right? Now, there is a trick that you can use to do these. Can anyone remember what the first thing you do, which seems kind of strange, but it works?
Make the second variable a 1.
So just for a little while, you pretend that the y was 1. The way that works, or the way that makes the question easy to do, doesn't it just get it back to a normal kind of trinomial that we're used to? And then this normal guy, you factor it in the usual way. No, you don't. I have to change my question. Now you do. So what combination is going to work here? It's so trivial that I should have made sure that I wrote the right question down. Would you agree it's only +1 and +7 and there's not really anything to worry about? But you still have one more line to do, don't you? So to finish this question off, how does this allow me to figure out what the right answer is, the final answer is? So how do I take this and convert it into what I need?
Add the y back in.
Right, so 1 becomes 1y, and the 7 becomes 7y. Just put the y back in. That's actually a nicer way to say it. It wasn't the way I was going to phrase it, but I like that phrasing, so I'm going to keep it. Right, put the y back in. Now, if you want to check, trust me, if you FOIL that out, it works. And that's what you're trying to do, right? You're trying to find something that you factor it, and it gives you the same thing you started with. I think that went, well, I can only tell by looking at faces. I think that went okay. I mean, it looked worse than it is, really, doesn't it? Once you do the little make y equal 1 trick, it is a lot easier. So let me hit you with a roll of horrible one. I'll let you do it first. I'm going to go 5x squared plus 2xy minus something. I need a minus something. There. You got 30 seconds. Go for it. Okay, here goes. We'll do this fine. You make y equals 1. So it now becomes 5x squared plus 2x take away 3. So that would be of the complex trinomial type. Right? 5x squared. That's a nice one that only has one choice. And really, we're just figuring out two numbers that make neither 3, aren't we? And the goal is to get plus 2x. Not many choices, again, thankfully. What one would work in this case? What numbers go here and here?
-3 plus 1.
Do you notice that after a while, I hope after a while, don't you start doing it in your head? You just imagine numbers and you do it and nah, it doesn't work. You imagine another number. Oh, that's the one I want. When you can get to that stage, it will make these questions a lot speedier, right? They will go a lot faster. But don't worry if at the beginning it takes you a while, because you have to kind of build up to speed, you know, until you get comfortable with them. And that's okay, that's normal. But hopefully towards the end of these kind of questions, you start really ripping through them a lot quicker, because you're now into that factoring mode where your brain's used to, oh, you want me to do that kind of thing. Right, now I know kind of, you know, what I'm meant to do in my head, and it goes smoothly. Okay, so what is left? You probably can't see this, but that's okay, I'm going to use them anyway. I've taken copies of the homework assignment, the last one that you need to do for Sunday, and it's basically got a lot of these factoring questions in them. And so what I thought I would do is I would just pick some random questions, random homework questions, just to show you, you know, what you're being expected to do. So let's see if I can find my first victim. Okay, this one is question 7, and it has 7p squared on the top, and it has 14p plus 10 on the bottom. And then we're going to multiply this fella by p squared take away 25, and on the bottom we're going to have 14p. So we're still going to be doing that factoring thing. All that's happening then is that we're going to add some steps that we've seen last time. Aren't you going to do the cancelling? The guy in the top kills off the guy in the bottom, right? And what's left is our answer. So in this particular case, let's do some factoring. 7p squared is good. Can you factor p squared minus 25? Yeah. Somebody want to tell me the name we give to that guy? The ones that look like this?
P squared.
You might have said it, but it was very faint if you did. What do you call p squared minus 25? A difference of 2 squares. Right. I was seeing lips moving, but not hearing, and that's what I thought she was saying, which is right. Now, the 14p, I know it's a little bit weird, but I'm just going to call it 14p. What about 14p plus 10? Can that be factored, even a little bit? In fact, if you don't do it, you're actually not going to get the right answer. So sometimes you can get caught up on the easy factoring. There's not an awful lot you can do to that, but can't you pull out a common factor of 2? So on the top, I've got this term, and this term. On the bottom, I've got these terms. So what I need to do now is cancel. Remember, it's a 1-for-1 deal. Darn it. I apologize. It's 14p plus 70. I wrote the question down wrong. I will zoom through it really quickly because we've already, basically the top was identical. Now 14p plus 70. That does factor as well, but what's the common factor now? It's not 2. 14p plus 70, what's the common factor now?
7.
Can we do better than 7? Well, let's show you what would happen. You might have this as scratch paper. Okay, I'm going to take out 7, which does work, and I'm left with that. Now, when you look at that, do you see you can pull out a little bit more? Another 2 worth. So when you pull out another 2 worth, you get that. And that's okay, because that happens at the side, so nobody sees it, right? So 14, p add 5. Now I can do what I was hoping to do the first time. You ready? Is there anybody in the top? And there's a lot of choices. So pick anybody in the top that you want me to cancel out the same guy in the bottom.
P plus 5.
Okay, that was kind of the one my brain went to first. Can that p cancel out with some of this guy here? Huh? This p in the bottom? If it cancels this out, don't you leave 1p behind? Okay. Can this 7 cancel with anybody? Yeah. Now, when I cancel it, don't I only cancel it with one of them? I don't say into that 2 and into that 2 and get 2 lots of 2. That doesn't work, right? It's a 1-for-1 deal. One thing cancels with one thing. Now, when I do that, let's see what we have left. I have a p. I have a p take away 5. In the bottom, I've got 2, a 1, and a 14, so I guess that's 28. And we are finished. Are we good? I'm going to share something with you. You see that question up there where I wrote the wrong number? I'm going for the sympathy vote here. Right? You know I'm old, so I forget things, so I use that a lot. I wear glasses, which is obvious. What you might not know is that I'm virtually blind in my left eye. I can't see a damn thing worth talking about. I was born that way, so it wasn't an accident or injury or anything. And it has, if I shut my right eye, I can't read. Do you know the board you go to and you know cover your eye? What letters can you see? I cannot see the top letter. I don't know if it's an A or an E. I sometimes know it's curved or straight. That's about as good as you get out of that eye. So you get a picture of how bad that eye is. Now, if any of you have got one bad eye, you'll know where I'm coming from here. Do you know that depth perception is really difficult because you need two eyes? And do you know scanning horizontally is also very difficult? So when I go here and I read something, and then I come back and then I go and read, very often I read the numbers from question 3, but when I go back, I read the number from question 4. So I make this monster question, which is a bit of 2 questions, none of which work. So that's kind of what happened here. So if you're wondering about it, but it's kind of fun. There are some weird things that you get by only having one eye. It's a bit like being a cyclops, I guess, if there was such a creature. Very poor depth perception. I've got a little bit because there's some residual sight in that. But I'll give you an example. I have never seen a 3D movie. I have been to 3D movies because my wife's eyesight's fine. Because when she wants to go, you go. And you know how you wear those little glass things? I don't see a 3D movie because do you know how that works is one eye gets to see one half of the picture and the other eye gets to see the other half, and it's the two together that fills your brain into 3D-ness. I don't know what a 3D movie looks like. I can imagine what it looks like. Please tell me it's not that good. That way I don't feel so bad about never seeing one, right? But that's one. It's not that good, right? 3D movies are overrated, right?
They hurt my head.
Say again?
They hurt my head.
Oh, okay. So you don't like them anyway, so it doesn't matter. Couple other things just to show you how much fun it is having only one good eye. Door handles are an issue. I miss door handles. I think that I don't miss them by feet. I miss them by inches, right? So sometimes I'll take a swipe at where I think the door handle is, and I miss it, and that's okay because then you just pretend you never did, and you move forward a little bit. But sometimes I miss it the other way, in which case it hurts. Yeah, you're back. And now the last thing to share with you with one good eye, parallel parking. You might think I'm the worst parallel parker in the world. Don't park anywhere near him when he's around. I'm actually probably one of the best ones, because when you do it and you look in your mirror and you're trying to judge how close the car is behind right as you're coming in, my brain thinks things are really, really close, right? So when I look at the mirror, I think to myself, I'm going to hit that car. I'm going to hit that car. And so I go in really, really slowly. So you'll know me parallel parking. I'm the guy that takes 5 minutes to do it, right? I'm coming in to do it. And then sometimes it gets that bad. I have to stop. I'll go out of the car. I'll look, and there's about 6 feet there. And then I'll come back in. And within 0.1 of a second, my brain will say, pay no attention to that. You're going to hit the car. You're going to hit the car. So you just have to brave it and you come in. So I'm really slow and really good at it and really careful. Because you know, if you think you're going to hit something, you're probably, when you're miles off, you're probably never going to hit it, right? Because you're very careful about it. So are we cool with, did I get a lot of sympathy points there? Okay, good. That's what I was going for. Right, let's pick another one of these guys. That was a multiplication one. I'll try and write the whole thing down before I stop doing it. This one is question 8. By the way, when you come to do these questions, you will find that my question 8 won't be necessarily yours. Because one of the cool things about this software is that they change various numbers. So if you did a question and you phoned up Janice and you said, how do you do question 8? She won't see x squared plus 6x plus 9. She might see x squared plus 4x plus 4. And that won't be 8x squared, that'll be 9x squared. And then all the other numbers, they get mixed and matched. And the software does that. So really, what that does is that you all get a question that looks like that, right? It's got the same kind of structure as that, but the numbers are different. That's very helpful in a test. Can you see that the chances are that you're all going to get different versions of the same question? So you can't really, not that you would ever dream of doing it. You can't cheat and say, hey, John, I'm doing question 8. What are you doing? How do you do it? What's up? Because his 8's not going to be your 8, right? So let's see what we got here. X squared plus 6x plus 9. I'll take a volunteer. Anybody want to factor that simple trinomial for me? You got to hit the space bar because I've got you all on mute.
+3.
Both times?
Yes.
Agreed. Okay, this guy here is not a trinomial, right? This second one here is not a trinomial. He's a common factor, isn't he? Okay. Would you agree you can take out 2x as a common factor? And when you do that, you're left with what? An x and a -3. Does that look good? Okay. There's nothing I can do to 8x squared, so I'm not even going to try. Right? It's as good as it's ever going to be. What about this fella here? Because this is a really nice question. I like this. 2x squared take away 18. It's not a trinomial, right? There are not 3 parts to it. Would you agree that there's a common factor of 2? I'm going to pull that guy out. Oh, sneaky. When I take out the common factor of 2, isn't this a difference of 2 squares? So if you do your working in pencil, which I don't do, can you imagine that you'll now do that? So if you try to do this question as a difference of 2 squares right away, you won't get it to work. Because think about it. 18 isn't 4 times 4, and it's not 5 times 5, and it's not 9 times 9, right? It doesn't work. You had to take out the common factor of 2 before you could do the second part. Now, you know, have you noticed that when I do these kind of things, I use kind of violent terms like this kills that off? Right? I think it's my Scottish heritage. We are kind of violent people, so we like to think of things as being killed off, right? Cancelling is the word. So, is there anybody in the top that I can kill off somebody like him on the bottom?
X plus 3.
Okay, so this x plus 3, I guess with that one, right? Anything left in the top that can cancel out with somebody in the bottom?
X minus 3.
Now it's getting a little bit less to work with. Is there anything on the top that I can cancel something in the bottom?
The 2.
Okay. Anything on the top that can cancel something on the bottom?
The X.
And when I cancel this one with the x squared, don't you leave an x behind? I have a quick scan, but I think we're done, right? There's nothing left to kill. So a 1, an x plus 3, a 1 and a 1, that just means that there's an x plus 3 left in the top, right? There's an 8 and there's an x, and that's all that's left on the bottom. I think so, right? 8x, 1, 1, 1, yeah, we're finished. That multiplication got multiplied and simplified to there, and it only took basically, what, 2 lines to do it? The mean work was done here, wasn't it? All this factoring stuff. But once you get it factored, doesn't it? You die, you die, you die, you kill, you kill. You know, whatever's left after the battle, you are done. You want a story. This is not a joke, this is a story, and my usual distractions have kicked in because I'm talking about things killing each other. I'd like to tell you a story about my wife, who's American, and when we got married, we actually emigrated to Scotland. So I didn't actually emigrate to America. My wife emigrated to Scotland. I ended up here, obviously, but that was the plan. It was to do with parents' health and so on, right? So I emigrated, or my wife emigrated to Scotland. And when she got to Scotland, I ended up being a tourist guide. I mean, every weekend it was, hey, can we go to this castle? I haven't been to that one. Can we go to this place? Can we go to that place? So I got to see an awful lot of things. And one of the holidays we took was up to the Highlands of Scotland, and we went to a place quite near where the Robertson clan came from. And she went into, I love them as well, we went into a little museum and we were looking around the museum, and we went and came across a picture of a clan battle. The Scotland, we are a very violent country. We weren't killing the English, we kept in practice by killing each other. So we had clan battles, and basically clan battles were all the Robertsons had an argument with the Stuarts. And it can be, you insulted my mother, it doesn't take much, right? And there's kind of rules to clan battles. What would happen is that we'd decide that we were going to fight in this valley, in the Highlands, and you'd meet up on Monday, and you'd have a big fight. And the way that the Scottish clan system worked, because we were so violent, is that the battles were very, not a lot of people would survive on the losing side, right? There was kind of no quarter given kind of battles. They were very violent. And what also happened is that if there was a clan battle and your clan was beaten, and typically if you were sensible, what was left, they would run away. But then the clan that won would then immediately move to where you lived, and they would steal everything that wasn't bolted down, right? They'd steal your cattle, they'd steal any wealth that you had, and they became richer. So clan battles were actually quite profitable if you had a very good fighting clan, right? If you won a lot of battles. And what would also happen very often, and you had these battles, is that the clan that got beat, if they got beat really badly, the clan that beat them would basically say, okay, we'll let you live and stay where you stay, and we'll let you farm there, but you don't own that land anymore. You just work for us, right? So you give us whatever it is, a certain percentage of your cattle every year, and whatever you make, right? So you kind of work for us. You don't own your land anymore. And when that happens, your clan is called a sept, S-E-P-T. So if you do have Scottish ancestry and your name's Stuart, actually they're a big clan, so that's a bad choice, and your name's McGregor, you might look into it and you'll say, oh, I'm a McGregor, sept of the Stuarts, which means sometime in my past, most of the time anyway, we get beat up by the Stuarts and they took over our land and they said, you're in our side. A couple of other things that happened when you're a sept. See, when you had a clan battle, you were obliged to join them in the battle. In other words, that was their way of getting more people as well. Anyway, back to I know it's a long intro, but back to the story. My wife was looking at a clan battle, and the Robertson clans were fighting a clan battle. And very often clan battles involve 2 or 3 clans who are friendly with each other, ganging up on another 2 or 3 clans that they don't like. So it's, it can be a mixture like that. And she said, oh, there was a battle and the Robertson clan were in it. And I immediately said to her, okay, who beat us this time? Because I already knew this part. The Robertsons never, ever won one clan battle. I never, as I looked up the history, I gave up looking because it was depressing. Anybody who fought us, we were beaten. And there was another funny little thing that I noticed. We were never the sept of anybody, which was quite curious because you would think we'd eventually get taken over. So anyway, there was a clan battle, and she said, I said, who did we get beat by? And she said, no, you actually won. You were in the winning team. And I missed that one. I thought, oh, cool. And I went over, and that's exactly what happened. Essentially, they give you a little description of what the battle was about and when it was fought and so on, who fought in it. And essentially, the description said, the Robertson clan turned up late. The battle had already happened. They were already in the middle of the fight, right? And the Robertson clan turned up late, and our clan chief had a moment of inspiration. And he looked down at that battle, and he said, that team over there is winning. We'll join them. And we were in the winning team, and I thought, bloody heck, that was a clever trick. Start a fight, turn up late, figure out who's winning, and join the team, right? But they never did it again. They did it that one time. And I don't know why, but this is my reason. I think what happened is that the other clans probably said, that's cheating. You're not allowed to do that. If you do that the next time, we're going to stop killing each other and all of us are going to kill you instead. You know, that kind of threat. So we said, we ain't doing it. And then after that, I went and found out later why no one had ever taken us over, why we were never a sept. And it was because the Robertsons live in a place called Loch Rannoch, and the land to the north of it is called Rannoch Moor, and a moor is basically a bog. So we lived in the most inhospitable place in Scotland. Nobody wanted the land that we lived on. That's why we got to keep it. They took one look at it and they said, that bog, no use to nobody. You can't grow nothing. Who wants it? Yeah, you could stay there. We don't care. So that was a story about the Robertson clan. So if you do find that you've got Scottish ancestry, look out for the little sept, if it is. Now, most of the time it was clan battles, but sometimes it was just for good reasons. Occasionally a clan chief wouldn't have any sons. He would only have a daughter or maybe daughters. And it kind of had to go son to son to son. And you don't want your clan leaderless, because it becomes a kind of clan that people will want to attack and, you know, do in really quickly because you don't have a structure. And so what very often would happen is that the women would marry the clan chief of a clan that you were friendly to, and your clans would basically merge because of that. So you could become a sept just because of marriage. I mean, that did happen. But most of the time it happened because they beat you up. Okay. Isn't it cool the things you learn in your math class that have absolutely nothing to do with factoring? But it kind of helped me, and I hope it helped you, to give you a little break, because we're about to do our next question, and I'm picking number 10. And number 10 is 5t squared, take away 16t, take away 16, all over 20t squared, take away 9t, take away 20, times 16t, take away 25, all over 4t squared plus 21t plus 20. That question should make you shake. That is horrendously ugly. Would you agree? There is no way of, you know, making that pretty. That guy is bad, right? So you're all going to help me. So there are 4 pieces to this. So I want some of you to just work on one of them, and then we'll put all your answers together like a combined effect, right? So when we're finished, it's going to be here. So I'm going to go out and in, and I'm going to, right, I'll put little numbers on them. This guy's called 1, this guy's called 2, this piece is going to be called 3, and this piece is going to be called 4. And I'm going to give you a job of working on just one of them. So, McKenna, Hannah, Mark, Hannah, I killed your name, didn't I? You know who I'm talking about, and Ian. Right, you 5 guys, up to Ian, you're going to do number 1. Erica, Michael, Christian, and Evan, you're going to be doing 2. Eric, Jason, Jessica, and Lucas, you're going to do 3. And Samantha and the others, you're going to do 4. Right? So you all know which one you're going to try and fix for me. 1, 2, 3, or 4. I'm only going to give you 2 minutes, so that's not a lot of time. So hopefully you can get only your piece done in 2 minutes, right? Just one of those 4, nothing else.
Could I really quickly see 1 again so I know what it is?
Oh, I apologise. You better actually, all of you see. I think it's not fair to give you a question that I just scanned through very quickly. There it is, right? So you'll know if you're 1, 2, 3, or 4. I actually think team number 2 got lucky. But, you know, maybe not. We'll see. Whoever is in team 3, sorry, that is one ugly, ugly one to do. So if you don't manage to get it in the 2 minutes, I understand. I probably can't do it in 2 minutes either. Oh, I'm trying 3 right now. I am having real trouble with 3. Oh, I think I might have got it. No, I'm wrong. Did anybody get 3 yet? I'm still working on it.
Still working on it.
Yeah, me too. It's just that there's 10 and 2 and oh god, there's 20 and 1 and what 5 and 4. So I think what I've done is I've done my classic. I picked the wrong one. Right, I'm not getting the one I need. I'm still working on it. So there is a cheat that I can use later. I'll see if it works. Okay, time up. Anybody want to volunteer the first one? At least I know it's 5 TNT. Agreed? There's not much you can do about that. Which one works for question the first one? Anybody from team 1?
5t plus 4, t minus 4.
You're going to put a 4 here and a 4 here? Is that what you're saying? So you're putting a plus 4 here. I'm just making sure I write it down correctly. This one. Okay, let's double check it. Minus 20 plus 4, you nailed it. So, done. Okay, team 2, I think, got an easy job. If you know what you've got here, would you agree that's, well, you tell me, what do you get? Anybody from team 2, how does this one factor?
4t plus 5 and 4t minus 5.
Do you recognise it as just an ugly difference of 2 squares? Whoops, that's a 5. Okay, I'm going to hold on to 3 in a minute. I'm going to show you a cheat, hopefully a cheat. Number 4, which is this one here. How does that come out? I believe it's a 4t and a t. Great. Is it? Oh, changed my mind. I thought it was a 14 a t because it looked easy. I'm not so sure now. No, I don't think it's a 4t and a t. Anybody got 4 that works? Let me check it is actually the right question. It is. So let's do some working over here, see what we get. Anybody can join in here, right? So it either splits as a 4t and a t, or it could split as a 2t and a 2t, right? And my superficial thought was it was 4 and 4, but I'm not so sure anymore. So if I do 5 and 4, what am I looking for here? I'm looking for 21. That's the key here. Well, that's never going to get me 21 because that's always going to give me even. So I was right to go that way. But getting 21. Does that get you 21? Let's see, 16 add 5. Agreed? So it is going to be 4t add 5 and a t add 4. And if you double check that, I believe it's correct. 16 add 5 more, it works, right? Now this stinker, there's no two ways about it. That's like the worst look. I could give it to Calc 3, they'd probably look at me and give up. There are so many ways of doing 20t squared, but I'm not going to do any of them except these two. And it's a little bit of a cheat, and I understand that, and it won't always work, but in this case I think it does. What am I getting at? Do you notice that in this question there's going to be some cancelling? So I'm making a judgment call here that I suspect that these guys are probably going to be, at least one of them is going to be related to this guy at the top. So do you see, by making it a 4t or a 5t, I've got a fighting chance I'm going to kill someone. McKenna, you got a question?
I think I got number.
I'll take it. Tell me what you've got and we'll check it.
5t.
I need a number. I think, have you got, I can't hear you.
I think she lagged out for a second.
I think it's 5t plus 4 and 4t minus 5.
So let's see, what am I after here? I'm after -9. So -25, add 16. Guess who nailed it? You got it.
Nice job.
Woohoo! Well done. Hey, wouldn't it be nice if you could have 30 people working on all your work and you only needed to, you know, pick someone's brain? That was cool. Well, let's get this guy out of the way now. Tell me anybody in the top that can get killed off by somebody in the bottom. Plenty to choose from, just give me anybody.
5t plus 4.
Okay, I'll kill those two, right? Anything left in the top that can be killed off by somebody in the bottom?
4t minus 5.
That one will kill off that one. Anybody else left?
4t plus 5.
Are the two guys that left okay? You can't do much with those two. So the final answer? Wow. The ugliest looking, that is, yeah.
So silly.
That is ridiculously ugly. But look at how nice the answer is. I mean, mathematically, that is a mess. Mathematically, isn't this very elegant? It's very nice, it's nice, easy. If I was going to calculate what this was equal to when t is 20, can you imagine how much work I'd have to do? If I wanted to get the answer, can't I just say 20 take away 4 and 20 plus 4, and the answer is 16/24, which is 2/3. See how much easier it is to calculate it when you simplify it, right? Pick any number you like. If you had to calculate that, that would be a really long, messy question. But if you know what it simplifies to, you can calculate it a lot easier. So that one took a bit longer, but that's fine. I have found out that you are very good at factoring as a class, and you're very good at working together. Okay, so to complete this process, I'm just randomly going to pick one division, and we'll call that good, and then we'll have a little break, and then when we come back, we'll talk about add and subtract. So this one is question 14, and it's going to be x squared, take away 14x, plus 49 on the top. And on the bottom is going to be a 4 take away x squared. And then we have a divide. And then we have an x squared, subtract 49. And then we have an x squared, subtract 7x, plus 10. And I guess I should put some brackets around everybody. Since this is the first division that we've done today, I have to remind you that don't you have to turn the second guy upside down? And it then becomes a multiplication. Do you remember that little trick? It's just a magic rule that we tell you, right? If you want to divide two things, turn it upside down and it becomes a multiplication. So this question is now just like all the others that we've been doing for the last half hour, isn't it? So we have got 4 guys and we're going to factor them. I think the good news is, would you agree that these 4 guys are going to be a lot easier to do than one we just did a minute ago? Because aren't they just difference of 2 squares or trinomials, and simple ones at that? So let's do, that guy's going to break as a double, that one's going to break as a double, so is this one going to break as a double, and finally, so is that one going to break as a double, right? So really all we need to do is figure out who goes where and start cancelling. Okay, x squared, take away 14x plus 49. I'm looking for an x and an x, right? 2 numbers that multiply together give me 49, but when I combine them, when I add them, I get negative 14. Would you agree in this case?
7.
7, positive 7.
Not plus 7, but
Negative
both
7.
negatives. Yeah, agreed. Both negatives, right? Right, in this case here, isn't it going to be 2 x's again? 2 numbers give you plus 10, right, when you multiply them, but when you add those 2 numbers together, you get negative 7, so that definitely means one's a plus and one's a negative, right? And just go through all the ways of getting 10, and one of them will work. It should work.
Shouldn't they both be negatives?
Let me check.
Yeah, -5 and -2.
Because it's a positive 10.
Yes. Thank you. Right. 2 negative numbers now that give you negative 7. And I think you already mentioned it, didn't you?
5
say
and
2
2,
5?
yeah.
Yeah. Okay. This one is a difference of 2 squares. So the 2 goes first. Great. And x squared minus 49, I don't think I can screw that one up. Isn't that just a difference of 2 squares? And now we're going to do some cancelling. And I'm glad it was just coincidence, but I'm glad I actually picked this one because there's a little twist in the tail that we're going to have to deal with. You might see it coming already. Right, if you take this x minus 7, can't it cancel out with that x minus 7? Right, is there anybody else that can cancel in this world? Well, you see this guy here? He's not 2 minus x, but he is similar to x minus 2. I think the book calls them opposites of each other. So this is the opposite of that. And opposites happen when you get, x take away 2, 2 take away x. X add 7, 7, not x add 7. X take away 7, 7 take away x. You are allowed to cancel opposites, which is why I like this question. But when you cancel them, you don't just leave a 1 behind. Don't you leave a negative 1 behind? And what that means is basically my answer's negative. So I'm just going to stick it over there. So anything else left after that? Not that I can see. So what am I going to get? I'm going to get a negative, those 2 guys, and those 2 guys, and those 2 guys, and those 2 guys. And that's the answer. You comfortable with that? I know I can see some puzzled faces, but essentially, I'm showing you just a random example. Those are opposites. They are allowed to cancel, but when they do, a negative 1 is left behind. It's just a little rule that you remember. Right?
It's the same as if you were to factor that by -1 on the bottom, correct?
Yeah. I like to stick it in the middle. That way I don't need to worry about who gets it. It just looks nicer. That's just me. If I remember right, didn't we do a question yesterday where they gave you, is this the same as that? And is that the same as this? And they give you different ways of writing where to put the negative. I just stick it at the side, and I do it that way all the time, and that just is a convention that I use. Your dog wants some attention here, Mark. So I'm going to give you a 5-minute break so that Mark and his dog can get his dinner or whatever your dog's looking for, right? And when you come back, we won't spend too much time. I think you've probably had enough put on your brain right now. So when you come back, I'm just going to give you a quick intro for about 20 minutes on add and subtract. You don't need to know it for this Sunday anyway, right? That's work that's going to belong to next week, so I don't mind too much. And that is it. So I'm just going to hang about and chat with anybody who wants to tell me stuff. And for the rest of you, go and have a coffee or do whatever you want for 5 minutes, and we'll get started. Okay, let me have a chat if you're still here, Michael. Michael, what's your job? What are you going to do?
Well, I own my own construction business right now, but I'm moving on to the technology sector, hopefully.
So you don't see yourself doing that job when you're 50 because you're probably going to bugger your body up somehow?
Yeah, exactly.
Yeah, I hear you. Totally sensible decision. When you're young and 20, you can do a lot of stuff, but add 10 years to that and your body starts hurting, right?
Yeah, exactly. Longevity is what I'm looking for.
Yeah, you want to be here to enjoy some of the money that you're making, right?
Yes, sir.
So any particular career in the technology sector? Are you thinking in something to do with computers or engineering, or you figured that far ahead yet?
I mean, I'm going to take this semester to think about it, but probably working on automated systems or, repairing electronics or something like that.
Okay, that's interesting. And do you know how much classes in the math that you need for that? I'm sure you need to go as far as probably, I'm guessing, 141?
Yeah,
you need more than that?
I haven't looked into it too deep. I might do some kind of engineering too, so I don't know. I'm still on the fence. We'll see.
Right. It's early. I mean, you've still got plenty of time to look at it. One of the suggestions I might look at is that if you're doing a particular class, sometimes they have a math prereq for it. So it's a good idea to just, if you've got time to look through, a catalogue and say, oh, that's a class I'd like to do. I wonder what you need to be able to take it. And they'll say things like, you need to have taken math 141 and you need to have taken, I'll make this up, physics 202 or something. And so you go and say, okay, I better make sure I get those classes done first. Yeah, so that I can do that class. So that's the kind of planning. The best person to talk to is not me because I don't know enough about advising people. But you should have an advisor by now. I know it's online, but do you have one?
Yeah, I've talked to one and she referred me to another one.
Okay, so someone who's more in the field that you're interested in going to.
Yeah, exactly.
Right, perfect. What are you going to do, Hannah? You got a plan?
I want to go into nursing.
So nursing. I got a lot of stats people in my classes right now doing nursing. Are you looking into same kind of questions? Do you know what kind of classes that you need that they want? I'm pretty sure they want biology. I know that they like statistics and some other things. So I'm don't do this if it's not what your advisor says. But I suspect that after this class, you're probably going to do statistics, Math 146.
Yeah, is what. Yeah, I'm
That's
already
what they
enrolled for
told you.
that in fall.
Okay, yeah, I think I'm teaching that in the fall. You know, if you get me 2 classes in a row, you end up with the same jokes twice. So I'm just warning you in case you don't want to get bored stupid. Yeah.
Yeah. Right now I just work at Little Caesars, so.
Yeah, but yeah, I have no problems with people working in jobs. I mean, give you an example. Most students are poor, right? Occasionally your dad and mum are really rich and, you know, that's lucky, that's great, but not me, right? So I came from a very poor family too. So you just did jobs. I did some weird jobs during, you know, to make money, you know, just to survive. I was a postman. During the Christmas, you could be a postman, right? So just during the Christmas break, they didn't give you any of the clever jobs to do. You know, I didn't do anything really fancy. All I basically got was the mail, and then in Britain they have post boxes, which are little slits in the door that you can put things through. And most of the time it was, you know, cards, and you just put them through number 42, move, put them through number 44, move. You just walked around and posted. It was a really, really boring job. I got a job in a warehouse, and my job was to drive a forklift truck and move pallets around and just generally, you know, pick things up and put them into a package that get wrapped and sent to whoever ordered it, right? So that was my job. Now, you remember I talked about I only have one good eye? Do you know a forklift and trying to put it into those pieces of wood? You know what a pallet looks like? People used to come and watch me because it was so much fun. You know, I would go up and metal, missed it. Down, you know, down a bit, up a bit. Oh, gotcha, right? That was. By the way, that was a boring job as well. What else did I do? Oh God, I had another job. I think it must have been that boring that my brain has decided to blot it out from my memory. I did know that after I did those jobs that I never wanted to work as a postman, and that I never wanted to work in a warehouse. I knew pretty much there and then that kind of career, and it's a great career, and I don't want to demean it because it's not an easy job. It's just not a job for me, right? For instance, I could never be a doctor or a nurse. I am far too squeamish, right? I'd faint, you know. I know I'd be useless at the job. I couldn't work in a home, you know, where dogs, you know, homeless shelter for dogs, whatever you want to call it, right? That thing, because I'd end up bringing them all back home, you know. So you got to know where your weaknesses are, and I know a lot of things that I'm not good at and would never be good at. So I'm glad I found a job where I enjoy it and I get to talk a lot because I love talking, as you probably know. Okay, let's get started and we can finish today. We're going to just do a very basic intro to add and subtract rational expressions. And before I forget, I'm going to take a screenshot of everybody so that you get your attendance. And so if you can just bear with me for a few seconds more. Where the heck is that thing? Oh, here it is. Okay, so let's go back in. We're talking about how do you add and subtract rational expressions. So let's talk about numbers first before we get too messy. When you want to add or subtract fractions, because that's all rational expressions are, as long as the bottom number, the denominator, is equal, isn't the process you just add the top two guys together and you keep the bottom guy the same? Great. Now, what happens if one or both of the bits happen to be a variable? Well, would you agree in this case, although the bottom is an expression, right? It's an x, but isn't it still the same x for both of them? So if I wanted to add these together, the rules do not change. I don't get 5, 2x, right? I don't add the tops and I add the bottoms. You see, you only add the top and the bottom stays the same. Now, can I subtract? Well, the good news is, yes, you can. And isn't subtraction and addition pretty much the same rule? Agreed? So how about upping the ante just a little bit? And suppose I have x over 2x plus 1, and I want to add an x plus 1 over 2x plus 1. Now, I don't know if brackets help, but if I put brackets around it, don't these two guys share a common denominator? That's the language that we use, right? They share a bottom number. They have the same bottom number, right? Then that means you add the top two terms together and you leave the bottom one alone. Now, in this case here, you then combine like terms. And sometimes, if you're really, really lucky, doesn't something nice happen? Can we simplify this fraction? And if I take this guy and cancel it with this guy, remember that you're leaving one behind. These two fractions added end up being equal to 1. So this process of adding and subtracting fractions does allow you to take complicated expressions and reduce them typically into something nicer looking. So far, so good. How about this fella? Now, they're still sharing a common denominator, right? So can't I just add the tops together? And superficially, you might say, oh, that's a nice answer. Can I move on? No, you can't. Because one of the things you need to do with these questions is simplify as much as possible. Do you recognize x squared minus 9? Do you see where this is leading? You see this x squared minus 9 is a difference of 2 squares. Can I cancel anybody in the top with somebody in the bottom? For sure. Right? And remember to leave that little 1 behind. To me, that's helpful. Because in this case, isn't there a 1 on the top and an x minus 3 in the bottom? And now we are finished. Now, the types of expressions that you are going to add or subtract are quite restricted. We don't expect you to add, you know, horrible fraction plus another horrible fraction, right? That's not part of this course. That's not where we're going. So the good news is that adding and subtraction of fractions is, for the most part, not all of them, but for the most part, we're going to share a common denominator, right? Which really helps, okay? But there are some situations that we're going to have to deal with. And this is one of them. The two fellas do not share a common denominator. In fact, that guy's not a fraction. So you're going to have to deal with a question where one of the terms is not a fraction, right? One of them will be a whole number, 1, 2, 3 typically. And now we have to figure out how we can add these two together. That's the only other situation you need to worry about. How to add and subtract two guys with the same common denominator, right? Like this. Or how to add and subtract when one fraction is being met with a number like 2, 3, 1, whatever. Any suggestions before I show you how you might approach this problem, how you could fix it? Because right now, I'm not allowed to say 3 add 2 is 5. That doesn't work. Just doesn't.
3 over 1.
I like your start. Good start. At least I've got a fraction. I'm going to write that again because it looks wonky. I'm not doing anything, right? It just looks nicer now. Okay. Now, how can I change this guy so that I can combine them with this guy? Well, doesn't this... Say again?
3 over x.
Very quiet. I don't know if it's my sound or your sound, but I couldn't hear what you said.
3 over x.
3 over x? Is that what you said?
Multiply them by x plus 1.
Right, I've not done anything to this guy, right? It's the same guy. You might think, what the heck's going on here? Isn't x plus 1 over x plus 1, 1? If you multiply something by 1, don't you not change its value? It's still worth the same. Just you change what it looks like. So if I take this guy and I multiply the top and bottom by x plus 1, and that wasn't random, wasn't it? Because this guy here was x plus 1. What I now get on the top is 3x plus 3 over x plus 1 added to 2 lots of x plus 1. Things looking good? Now, since they share a common denominator, can't I now just add the tops together and then tidy it up? In this particular question, aren't we finished? There isn't anything that I can cancel or simplify. Can we pretend that I had a different question, right? Different pieces to it, and it ended up being that, right? Right. So imagine I gave you a different question and we added them and I got this. This one's finished. This one is not finished. This one can be simplified. Is there anything on the top? Or there is on the top. What do I factor the top? How do I do it?
Factor by 3.
And these cancel out. And if that was the case, wouldn't you be left with the number 3? But that's, you know, a different story. Are we comfortable about the basics of the types of things you're going to be add and subtract? For the most part, they're just going to share a common denominator, in which case the rule is just add the tops and have the same guy in the bottom. Factor it when necessary and get the answer by simplifying. Or it's going to be a number plus a fraction. And we've shown you the technique that you can use. And wouldn't the technique be virtually the same if you were subtracting the two? Right, so it wouldn't really change much if you add or subtract. And I think this is a good point for us to call it a day.